Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Reactivity of acyl derivatives toward nucleophilic acyl substitution depends on the electrophilicity of the carbonyl carbon. This is governed by two factors: 1. The electron withdrawing or electron donating ability of the leaving group substituent, and 2. The stability of the leaving group, i.e., how good a leaving group it is. Moving on to the next step. Identify the three acyl derivatives. Compound 1, an ester, CH3C, is equal to O, OH3, the leaving group is an alkoxide, Rho. Compound 2, an acid chloride, CH3C, is equal to O, Cl, the leaving group is Cl. Compound 3, an amide, CH3C, is equal to O, NHCH3, the leaving group is an amine, RNH-. Moving on to the next step. Assess the electron donation by resonance into the carbonyl. In amides, nitrogen donates its lone pair strongly into the carbonyl by resonance. Nitrogen is a better electron donor than oxygen or chlorine by resonance, making the carbonyl carbon least electrophilic. In esters, oxygen donates its lone pair into the carbonyl by resonance, but less effectively than nitrogen. Oxygen is more electronegative, lone pair less available. In acid chlorides, chlorine donates very little by resonance, poor pi overlap due to size mismatch of 3p orbital with 2p of carbon, and Cl is strongly electron withdrawing inductively, making the carbonyl most electrophilic. And for the final step, assess leaving group ability. Cl is an excellent leaving group, weak base, stable anion. Rho alkoxide is a moderate leaving group, stronger base than Cl. RNH amine is a poor leaving group, strong base, high pKa of conjugate acid tilde 35-38. Combine both factors to rank reactivity toward nucleophiles. Acid chloride, to most reactive, least resonance donation plus best leaving group. Ester, 1 intermediate reactivity, moderate resonance donation plus moderate leaving group. Amide, 3 least reactive, strongest resonance donation plus worst leaving group. Order of increasing reactivity, least to most 3 1 2. Why other options fail? A. 1 to 3. Incorrect. Amides are less reactive than esters. C. 1 3 2. Incorrect. Amides are less reactive than esters, not more. D. 2 1 3. Incorrect. Acid chlorides are most reactive, not least. Therefore, the correct answer is B. Therefore, the correct answer is option B.